Now for the next lesson, we're going to talk about when HONC does and does not work. And so the reason why we use HONC is that it makes drawing covalent compounds really simple. And so if you think about HONC, once again, it's HONC, and then it makes 1, 2, 3, and 4 bonds. But when we simplify things down like this, we always assume that every atom has a formal charge of 0. And so every single time we simplify it down where it's just 1, 2, 3, 4, we assume that every single atom has a formal charge of 0. And so this works for simple molecules when you don't have any charges at all. So for example, if you think about NH3, when we're drawing this as a Lewis dot structure, right, N needs 3 bonds, and we have 3 hydrogens, and so the simple way to draw this would be N has 1, 2, 3 hydrogens attached to it, and then in order for us to complete this Lewis dot structure, nitrogen needs to have 8 electrons, and so we add 1 pair of dots so that it has a total of 8 electrons. And so this works out really well because if you look at the formal charges of every single one of these elements, remember that formal charge is equal to valence electrons minus non-bonded minus bonds. And so if we look at the formal charge of hydrogen, in this case, its formal charge is equal to valence electrons is 1. And then we have 0 lone pairs on every single one of these hydrogens. And so there's 0 non-bonded pairs. Minus every single one of them has 1 bond. And so this has a formal charge of 0. So in this case, we assume that this is a 0, 0, 0. And then we look at the formal charge of nitrogen in this case. Its formal charge is equal to nitrogen has 5 valence electrons minus it has 1, 2 or 2 non-bonded electrons, and then minus it has 1, 2, 3 bonds. So we have 3 bonds, and so it has a formal charge of 0. And so anytime you have a simple molecule like this where we use HONC, we assume every single element in that case has a formal charge of 0. But what if we added another hydrogen, so we had ammonium, the polyatomic ion ammonium? At this point, we can no longer assume that we have only 3 bonds because we obviously have too many hydrogens that need to be attached to our central atom of nitrogen. And so if we drew this, it's nitrogen that has 1, 2, 3, 4 hydrogens. And this obviously breaks our conventions of HONC because now nitrogen has 4 things attached to it, which is not exactly what HONC states, right? And so whenever we start dealing with more complicated atoms, we have to use formal charges to predict the more stable atom. And so we have to use formal charges to predict the Lewis dot structure. And so in this case, we look at the formal charges and we'll see that each of these hydrogens have a 0 formal charge, and that this nitrogen now has a +1 formal charge, and that's why we have a overall +1 charge. If we wanted to draw the brackets, this has a +1 charge that matches with our positive charge of NH4 plus. And so anytime you understand or see a simple molecule, you could just use HONC. So anything that doesn't have any charges, you could pretty much assume a lot of the times you could use HONC. This also means, so this excludes things with charges, so polyatomic ions. But also, it excludes anything that has an expanded octet, because this only predicts that you have up to 8 electrons on every single one of your elements. But in the cases that we start having expanded octet, we will start seeing that we'll have to deal with more than 8 electrons in the center, which then breaks apart our normal conventions of HONC. And so this is where you have to start recognizing when we use HONC and when we shouldn't use HONC.